All right. So hi, everybody, and I hope you're having a wonderful day. You do not have a quiz this weekend. Yay, you get a break. Now, looking in your syllabus, you may have noticed that we have an assignment on the 15th. I'm going to go ahead and push that to the following week, the 22nd, just because that is something that we're going to talk about in logic and reasoning, and we're a little bit behind. So I'm going to go ahead and push back that last homework assignment so that I have time to explain to you what it is. Now, is anybody not going to be here on the 22nd? Because I know that some of you might be leaving for Thanksgiving break early. Is that anybody here? Make sure that you email your assignment to me or upload it to me. But I'll make sure next week after the exam, I will kind of explain what I want out of that assignment. All right. Okay. So the last time we were here, we were talking about chess. Did anybody go and look up that Broadway musical Chess after I was done? You didn't miss much. It's really okay. Like it's very 80s. So we're going to continue our discussion of expertise. And then we're going to move on to talking about judgment and decision making. Okay. Load, please. All right, here we go. Okay, so we spent a little bit of time talking about chess, but one other area that can be really important for expertise is medical expertise. So has anybody here ever gotten an MRI or an X-ray? Yeah, me too. And you want to make sure that whoever is viewing your scans actually knows what they're doing and that they have the expertise to be able to detect something that is normal from something that is not. And they need to be able to do so very, very rapidly. So here's what we know. Researchers have actually tracked eye movements for biopsy case slides. Now, has anybody here ever had a biopsy? Yeah, me too. I found a lump about 6 years ago. I found a lump. And here's the thing that they don't tell you. Lumps in your breast are normal. Most of them are not breast cancer. But if you find one, it's not the worst idea in the world to get it checked out. And additionally, if you're old enough, mammograms are free. So I think above the age of 40, you can actually get a mammogram every year as a preventative measure for free. But if you find a lump, they usually want to do like an ultrasound or a mammogram, and they might even take a sample. So for biopsy slides, fully trained pathologists, when you look at the eye tracking, pathologists who are very well trained and have more expertise actually spend the least amount of time extracting the slide. But so they don't really spend a lot of time looking at the slide. But what's interesting is that when you look at how much information they get from each fixation of their eyes, they actually extract more information from what they see. Additionally, for those doctors that are radiologists that spot cancers, most expert doctors can fixate immediately on cancer that is present in a scan. Now, here's a really funny story, though. So I don't know if you're aware of this. Do you remember early in the semester, we talked about the invisible gorilla? So we talked about that study with inattentional blindness and the moonwalking bear. The original study had a gorilla, and those same researchers actually put a tiny little image of a gorilla in radiological scans for doctors to view, and most of them missed the gorilla too, even if it's in their area of expertise. If you want to have a laugh at my expense or feel sorry for me, I'm going Christmas shopping tomorrow for my nieces and to get a dress for hanging of the greens. And I have to go buy a gift card at like Hot Topic. I have a niece who is working on developing her aesthetic, and her aesthetic is dark academia. Back when I was growing up, we just called that style, not an aesthetic. But yeah, I'm like, I have to go to Hot Topic. Oh gosh. Oh, I feel so old. All right, everybody good? Okay. So I want to finish up by talking about the notion of deliberate practice. So how does expertise actually develop? And this was something that was brought up by the late researcher Anders Ericsson for a while. So he was of the opinion that a wide range of expertise is developed through deliberate practice. So for those who may not know, I've been playing the tuba since I was 11. Now, I am by no means an expert. I do not have a music degree. I did not really do a sufficient amount of music training. And folks, for those who know music theory, when I see 16th notes that I have to play very quickly, I get scared. I'm like, I can't play that fast. I'm the oompa person. I'm not the da-da-da-da-da-da-da person. That is not me. But deliberate practice is very, very different from what you might think of as practice. So when I explain practice to you, you might think about just somebody like me practicing scales over and over and over again. Here's the thing about deliberate practice. Deliberate practice, you're always going to be upping the level of task difficulty to make it more challenging as you gain more skill. So deliberate practice involves the following. There needs to be an appropriate level of task difficulty. So the better that you get, the more challenging your practice should become. The learner should be provided with feedback. If you're not provided with feedback, you're never going to understand how to make your performance better. Lack of feedback leads to overconfidence. So something that you had to read about in You Are Not So Smart, and I'm going to be asking about on your exam, is something called the Dunning-Kruger effect. How many of you are actually already familiar with the Dunning-Kruger effect? So this is basically the finding. How many of you used to watch like American Idol auditions? Okay, and how many of you were always surprised that like the worst singers go in and think, oh my gosh, they think they can sing, and then the music comes out of their mouth and it's bad. Now, to be fair, some of that is just so they can get on TV, but there are some people that legitimately think that they are good singers, and here's why. They're probably surrounded by people who can't sing. And so they tend, or they go to karaoke night and they tend to be one of the better singers at karaoke night. Or they get involved in choir and they're one of the best people in choir. So there's not really a very good basis of comparison, and there's not really a lot of opportunity for feedback. So how many of you have had this happen? Some of you took general psych, maybe you took it in high school or you took it in freshman year, and you're like, I know everything about psychology. And then as you got into other psychology classes, you realized how little you knew. So something that's kind of interesting, and this is basically what Dunning-Kruger is, when you don't know a lot of information, you actually don't realize how much you don't know. So you don't really have a full extent of how much you know, and you also don't know how much you don't know, if that makes sense. The more knowledge that you gain, the more that you recognize the extent of how much you don't know. So if the only type of acting that I do is in community theater plays, and I'm always getting the lead, I might start to think, well, if I'm really good here, I must be good at, I'm going to go try out for a Hollywood movie. That's never going to work, because I have no idea of what I don't know. I don't have a good basis of comparison. So the Dunning-Kruger effect is that most people that don't have a lot of knowledge think that they're really good at things, and they tend to overestimate their performance. And one of the things that's actually kind of interesting is that the more knowledge you gain, and the more aware you are of what you don't know, the less confident you tend to be. So one of the things that you may be kind of surprised about is that I'm a PhD. I don't know everything about psychology. And I know that that's kind of shocking because I spent 6 years studying it in excruciating detail. But here's the thing about a PhD. You are very narrowly studying a very specific phenomenon. So my knowledge of memory is really good. My knowledge of cognitive psychology in general is less good because I spent most of my time focusing on memory, but my knowledge of cognitive psychology is certainly better than my knowledge of mathematical psychology or clinical psychology. So I'm very well aware with all of the knowledge that I have of where my shortcomings are. When you don't have a lot of knowledge, you're not aware of those shortcomings. And that's basically the Dunning-Kruger effect. So we need to get feedback. Otherwise, we're going to fall into this idea that we're really good when we don't have a very good basis for comparison. There need to be opportunities to repeat the task, and there need to be opportunities to correct the errors. Now, this next statement of Erickson's is actually really controversial, and I don't always know that I agree with him. And that makes me feel really bad because he was my cognitive psych professor. He was my cognitive psych professor at FSU, and he also sat on my honors committee. And it makes me a little sad that I don't agree with everything he says here. But Erikson believed that innate talent was not necessary, or that innate ability was not required. And to that I say, I don't know that I agree. Here's an example. Casey, if I practice really, really hard with the softball team at practices, and Jenna, you can say this too, if I practice really hard, am I going to be as good as you? No. If I practice every day and do deliberate practice for basketball, does that mean I'm going to join the WNBA? No. Also, I'm short. I mean, I'm above average, but I'd be short for a basketball player. I can run and practice and run intervals, but I'm never taking first place at a place like Boston Marathon. If I had to go up Heartbreak Hill, I'd die. I've heard stories about Heartbreak Hill. I am not even interested. So this is actually pretty controversial. Erikson believes you don't need talent, and talent, sometimes it matters. Sometimes you do need an innate ability. I have very short legs. It means I'm really good at deadlifting, but not much. And I have really long arms. They're great for deadlifting, but not much else. Okay, now let's talk a little bit about how deliberate practice can be used to do some pretty extraordinary things. So remember that we did a digit span task? In short-term memory, I give you a list of digits and you repeat them back. Most people can get about 7 digits. So with deliberate practice, it was well documented back in 1980 that a student actually managed to increase their short-term memory ability from 7 digits all the way up to 82. Steve Falloon, at the time he was better known as SF, he worked with Erikson and also William Chase. He actually spent 2 years practicing the digit span task for an hour every day. I can think of I love memory research, and y'all, I can think of so many better uses of an hour, like playing on my Animal Crossing island. Like this would be very boring for me. So one thing that was kind of interesting is that Falloon was a runner, and he knew a lot of running statistics and world records and things like that. So initially, he actually used his knowledge of running times to increase his digit span all the way to 18. And then beyond that, he kind of hit a wall at 18. And then what he ended up doing is he started chunking items together, and he actually organized the chunks into a hierarchical retrieval structure. So it kind of looked like this. Here's the whole list. And then he'd break it down into these chunks. And then he had these other groups of chunks. So it kind of worked like this. And by being able to do this kind of hierarchical retrieval structure, at the end of 2 years, he was able to repeat back up to 82 digits. You can get it if you really want it. But yeah, I didn't always agree with Erikson about everything. So I took his cognitive psychology class when I was in college. And one of the most controversial things he said that he didn't believe in dreams. Do you know why he didn't believe that people dreamed? Because when you wake up, you generally can't tell people about them. They fade. I'm like, that's really hard lined. Also, he was one of the few professors in the psychology research building who actually had windows in his office, and his office was huge, and it was way messier than mine. But no, he passed away like last year in 2020, and he will be very missed. So not everybody agrees with Erikson on the notion of deliberate practice. One of those people is Zach Hambrick. He is actually reported in your textbook. They basically found that in chess expertise and music expertise, practice only really contributes about 30% to the variability in performance that you see. And to be fair, that means that the other 70% has to be explained by something else, and that might include things like talent. Okay. Now, as I kind of mentioned, there are some potential issues with deliberate practice. Deliberate practice is not the only way that you develop expertise. Additionally, talent does play a role. Even Casey and Jenna can tell you that with all the practice I do to build up my athleticism, I'm still not going to be as good as they are. They have natural abilities and skills that I do not have. Additionally, what makes this kind of difficult is that when we look at the role of deliberate practice, many of Erikson's studies had people self-report their practicing habits. Experimenters did not actually say, okay, we want you to practice this way. We're following up with people that have developed a certain way of practicing for years. And so it's the experts that are controlling their practice and not experimenters. Now, if experimenters laid out a certain type of practice, what would that look like? And how would it be different from what experts choose for themselves? Additionally, why do individuals choose to engage in deliberate practice at all? What motivational factors are coming in? Additionally, this is a lot harder to apply to broad, complex skills. This works for very specific skills, such as athletics or chess or music. but it's going to be more complicated if we're talking about research. For example, research is a very broad activity with many, many different operating parts. And so those are often going to be a little bit harder to explain. But I do agree with some ideas. If you want to get better at something, you have to practice. I want to get better at German in time for the Vienna trip. The only way that I'm going to get there is by practice. I'm thinking about going to the Sigmund Freud Museum. Apparently they have a really good neuroanatomy exhibit. And I told the Gen Psych students I'd have to work very hard to not throw things. Also, if you do that in a museum in a foreign country, you usually get arrested. That doesn't seem like a very good idea, even if I don't like Freud. Right. Everybody good? Okay. So now we are talking about judgment and decision making, and these should be up. These should be up for you on e-learning. Whatever I don't finish in this section, I will record. I'm going to move pretty fast on Monday for sure, but whatever I don't finish, I will put up in a recording for you. So we're going to start by talking about judgment and decision making. And I think for many of you, this is probably going to be one of your favorite sections. Talking about judgment and decision making is certainly one of my favorite things to talk about in this class. And if you're interested in stuff like economics, and I know I say that word and I'm like, when I hear the word economics, my brain kind of leaves my head a little bit because that sounds like finances. And I don't like talking about finances or budgets. I've finally managed to learn how to manage money, but generally when the college starts talking about a budget at a meeting, my brain kind of leaves my head. But if you are not like me and you are interested in things like economics, this actually explains a lot of human consumer behavior as well. And you might actually find that pretty interesting. But we're going to start by talking about judgment today. So let's first compare the difference between what judgment is and what decision making is. So judgment is when we draw inferences about situations and events. The goal is accuracy. So our focus is on how accurate our judgments are. So if somebody cuts in front of me in traffic, my judgment is that they are probably rude. And I'm going to be focused on whether or not that judgment is an accurate one. Now, on the other hand, decision making is when we have to choose between different options. And the goal is not accuracy. You are never going to make the most perfect decision every single time. The goal is to think about what the consequences of that decision will be. Now, judgment is going to be required for decision making because we don't always know all of the options that are available to us at any given point. So if you had to figure how many decisions we make each day, how many do you think we make each day? If you had to put a number on it. Huh? It is 35,000. Well done. Adults make more than 35,000 decisions per day. So the things that and here's the thing, the things that you don't think are decisions are absolutely decisions, including what you're going to wear, what you're going to have for breakfast. Are you going to have something for breakfast? How much do you want to eat for breakfast? We make a ridiculous amount of decisions each day. And one of the things that I've heard that can actually be really useful, because all of these little decisions that you make every day, they take cognition. They take energy. And that means that at the end of the day, you actually develop decision fatigue. You're getting tired of making decisions, and so you tend to go on autopilot. What I would recommend, if you can, for certain things, simplify the decisions that you have to make. I eat pretty much the same thing for breakfast every single day. I like it. It doesn't take too much to think about, and already there, I've cut down on quite a few decisions for the day. It's also why people like Steve Jobs and people like Mark Zuckerberg wear the same thing every single day, because figuring out what to wear, huge decisions involved in that. So if you have kind of a uniform, it actually cuts down on decisions. Although I went to Catholic school, I had to wear a uniform. It just shifts what your decisions are, like what shoes do I want to wear today? Okay, so we're going to start by talking about judgment research. So I'm really sorry. I'm going to be showing you some math today. You're like, I didn't know there was going to be math. Yeah, I know. I'm sorry about that. Okay. So we're going to talk about something called Bayes' theorem. So one of the things that we find is that a lot of the judgments that we make, we typically do not make all of our judgments in a vacuum. Oftentimes when we are trying to make a judgment, we often will think about what has happened in the past. So when we judge how likely something is, we need to think about what the prior base rate of occurrence is. So here's kind of what that means. Is there anybody here that's afraid to fly? Is there anybody here who's afraid to fly on an airplane? Anyone? You all like to fly on airplanes? Cool, I don't. Now, occasionally I will find somebody who is afraid to fly. And for those situations, it's kind of helpful to point out to people how rare plane crashes really are. And so because of that, if you know what the prior rate of occurrence is, that can actually help kind of clarify that, yes, plane crashes are rare. And because of that, you should feel pretty safe when you're on a plane. Now, of course, for somebody that has flying anxiety, that never really works, because you're always like, what if this is the one time it happens? You know, but new information can actually change how we judge things. So we're often thinking about the likelihood of one of two different things happening. So what you're looking at here is the probability that a hypothesis A happens, given the data, over the probability that hypothesis B happens, given the data. And to get these, we actually have to figure out what the prior rate of occurrence is. So if we get a positive breast cancer test, for example, what are the base rates for things like false positives? Because false positives do happen occasionally. If you get a positive COVID test, what are the odds of a false positive? because just because it's positive doesn't always mean you're going to have it. So we need to look at the base rates of occurrence when we're judging the likelihood of something. So we need to assess the relative probability of events. We need to think about what's most likely to happen before the data are obtained. So for example, you already know if I flip a coin, what the odds are of a heads up flip, right? Yeah, it's 50-50. So because you know that, you can use that prior information to help you think about what's more likely. So I'm showing you this first because we're going to work through a problem together. So when you see this, this is the probability of a hypothesis given the data. This is the probability of the data given a certain hypothesis. Folks, I am not going to test you on this. Not this. You don't need to know this formula, just so we're clear. Like, I wouldn't do that to you. This ain't psych stats. And even in psych stats, I don't ask for formulas except occasionally. And they're usually things like, what's the formula for a standard deviation? Which is pretty straightforward. All right, Lauren, do you need a little more time? Okay, so let's go through the taxi cab problem and let's talk about how Bayes' theorem factors in. So a taxi cab was involved in a hit and run accident one night. Now, of the cabs in the city, 85% belong to the green company and 15% belong to the blue company. Now, in this hit and run, an eyewitness identified the cab as a blue cab. It turns out that this eyewitness isn't perfect. They're actually wrong 20% of the time in appropriate visibility. So what is the probability that our cab is blue? So what is the probability that our cab is blue? Any thoughts? You don't actually have to do any math. I see some people writing stuff down though, so I'll wait. Now, let's first talk. How many of you think it's more likely that the cab that's involved in the hit and run is a blue cab? How many of you think that the cab that is more likely to be involved in the hit and run is a green cab? Okay, for those of you that said green cab, why?
Because there's a higher chance that it probably is that.
Because there are more green cabs in the city. So for those of you that said it was more likely to be a green cab, I appreciate that you're paying attention to what are called our base rates. If you have way more green cabs in the city, odds are pretty good, despite the eyewitness identification, that most of the time it's going to be a green cab. Just because now some people will only focus on the eyewitness and they'll say it's an 80% chance that it's a blue cab. The problem is you are neglecting the actual true values in the population as well. Odds are pretty good because there are more green cabs. And because this witness is not a perfect eyewitness, that it might actually be a green cab. So here's some scary math to explain how we got it. The odds ratio is actually 12-17. So here we have the base rate of blue cabs over the base rate of green cabs plus the 80% identification, if it's correct, over the 20% that's incorrect for our eyewitness. When you take the eyewitness's information and multiply it by the base rate, that puts us at 0.12 over 0.17. When you put this together in an odds ratio, and you don't have to know how to do it, you just have to know that I know how to do it. So we basically, here are the odds for a blue cab, here are the odds for a green cab. So there's actually a 41%. So we take the 12% over the total, which is 0.29. There's a 41% probability that the taxi cab is blue. There's actually almost a 60% probability that it's actually green. Why? Not because of the eyewitness, but just because there are more green cabs out there. So think about this every time you hear something. Always pay attention to the base rate of occurrence. So you don't have to know how to do the math, but if you know that there's more green cabs out in the city than blue cabs, there's a chance that it could be a blue cab, but the odds are going to be greater that it's green. So why do so many of us get this wrong? First of all, most of us don't like math or don't know how to figure it out, and that's okay. But in general, without the math even being considered, most of us do not take prior base rates of occurrence into account. Base rate information is the relative frequency of an event or of an attribute. So in our cab example, green cabs are more common, but it's almost like the eyewitness account sucks us in and we forget that green cabs are more common. Okay, everybody good? Okay. So here's another example, and you don't need to write this down. Jack is 45 years old. So he's married with 4 children. He's generally conservative, careful, and ambitious. He shows no interest in political or social issues, and he spends most of his free time on his many hobbies. Now, these are going to include carpentry, sailing, and numerical puzzles. So right now, I want you to decide the probability that Jack is a lawyer, as well as the probability that he is an engineer. So go ahead and write a probability in your notes, or at least have a good idea in your mind of what you think is more likely. So how many of you, raise your hand, think that Jack is more likely to be a lawyer? How many of you think Jack's more likely to be an engineer? How many of you are like, Dr. Gilchrist, you can't decide somebody's career based on their personality? So one of the first major questions that you should be asking yourself before you decide this is, how many lawyers are there and how many engineers are there? Because odds are pretty good. Jack's going to most likely be whatever there is more of. So in general psychology, we do a really similar example with a character named Steve, and we have to judge whether Steve is a librarian or somebody who works in retail. Now, in terms of sheer odds, nothing to do with personality at all, what is Steve more likely to be? He's more likely to work in retail. That's where more people are. There are more retail workers than librarians. So does the same thing happen here? Do people pay attention to base rates, or do they focus on those personality traits and see if they fit a prototype? We don't think about the frequency at all. So in certain conditions, participants were told that Jack's description was selected from 1 of 100 descriptions. Half of the people were told that of these descriptions, 70 were lawyers and 30 were engineers. So in this case, you should be saying he's more likely to be a lawyer. However, in the other case, they're told that there are 70 engineers and 30 lawyers. So in this case, he's more likely to be an engineer. And yet, despite the different base rates, regardless of condition, most people say that there is a 0.9 probability that Jack is an engineer. Why? Because in your mind, you have a prototype of what an engineer looks like, and Jack fits it. So this is a very well-known heuristic for judging the likelihood of something, and this is called the representativeness heuristic. So we often will use heuristics, general rules of thumb, to help us make our judgments. And this was developed by Daniel Kahneman and Amos Tversky. They actually received the Nobel Prize in economics for their work in this area. There is no Nobel Prize in psychology. Psychology was not a formal discipline when the Nobel Prizes were started. So when psychologists get Nobel Prizes, they tend to be for economics, and not to brag a little, but they also tend to be cognitive psychologists. And I basically mean that there's three. There's Tversky, there's Kahneman, and then there's Herb Simon. And they're all looking at consumer behavior. So the thing about a heuristic is that it does actually help us judge likelihood pretty quickly, but it can lead to some systematic errors. So this first heuristic, you judged that Jack was more likely to be an engineer because of the representativeness heuristic. This is the assumption that typical members of a category are most frequent. We judge the likelihood of something based on how well it fits a prototype rather than focusing on base rates. And an event that is similar to most of the others in the population are going to be representative. Most of us have an idea of what engineers look like based on our experiences and based on exposure in society. And because of that, we're going to assume that Jack is more likely to be an engineer because he looks like most engineers. This is representative of most engineers. Everybody good? All right. So here's another problem for you. So Linda is 31 years old. She's single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. So I want you to judge the probability of these three things. What is the probability that Linda is a bank teller? What is the probability that Linda is a feminist? And what is the probability that Linda is a feminist bank teller? Okay, so raise your hand if you think it's most likely that Linda is a bank teller. Raise your hand if you think it's most likely that Linda is a feminist. Raise your hand if it's most likely that Linda is a feminist bank teller. Okay, so here's what's really interesting, and I'm going to pick on you, Amy, because I saw your hand. Okay, so why do you think it's most likely that Linda is a feminist bank teller?
I was just guessing.
Okay, there's nothing wrong with that. So here's the thing. This is how most people actually respond to this problem. So here's the thing about probabilities, though, and this is where it gets a little tricky. We think that being a feminist bank teller might be more common because, well, it kind of fits the profile. She looks like she's a feminist and, you know, she needs to have a job. So for whatever reason, feminist bank teller sounds better to us in our mind than just being a feminist, right? So here's what's kind of interesting about probabilities. So let's say that the probability of Linda being a feminist is like 0.3. I need an eraser. Ah. So let's say that the probability of Linda being a feminist is 0.3. So here's the thing. If I want to figure out the probability of being a feminist and a bank teller, here's the funny thing about probabilities for both of those things. They have to multiply. So if she has a probability of 0.3 being a feminist and 0.25 of being a bank teller, these don't add. They multiply. When you can join two probabilities like this, they have to be multiplied. So here's what's interesting. You multiply 0.3 by 0.25, you actually get 0.075. The probability of both of those events occurring simultaneously is less than either one of them on their own. It's actually more likely that Linda is just a bank teller or Linda is just a feminist than her being a feminist bank teller, because you'd have to multiply those probabilities when they're conjoined. So this is what is referred to as the conjunction fallacy. This is the belief that a combination of two events is more likely than either one on its own, and that is mathematically impossible. So people actually judge Linda as being a feminist bank teller as being more probable than just being a bank teller or just being a feminist. Isn't that interesting? It's almost like we don't know much about probability. If there is anything that I've learned in the past 2 years, we need to teach people more about probability, data literacy, and statistics. I care so much about this. And I'm not even that, no, I'm pretty good at math. I can't lie. Getting a B in math doesn't make you bad in math. Just means you're not perfect. All right. Everybody good? Anybody need a little more time? Okay, thanks, Casey. Yeah, don't be afraid to speak up. I get really excited talking about this stuff, so sometimes I move a little quicker than I need to. I'm even like that when I go on walks. I'm like, we have to make good time on the walk. Hurry up, dog. I need to get a good walking pace. I'm a little too type A, I think. Right, you good? Okay, one more slide and we'll finish up. So another thing that we can actually do is we also have another heuristic that is called the availability heuristic. So the frequency of an event, we often judge how likely it is based on how available in our memory it actually is. So my question for you is, what is the more common cause of death? Is it murder or is it death by suicide? Who says murder? Who says suicide? Good. Now, most people would actually, your average person would say that murder is more common. And the reason for that is that when somebody gets murdered, it's a huge deal. Like every time there's a murder in Nevada, it's rare. Like it's really rare. Somebody told me to be worried about the crime here when I first moved here. And honestly, I found it's really not that bad. It's just, for the most part, it's dinky little property crime and stuff like that. But when a murder happens here, it is a huge deal because it very rarely happens. Now, suicide is more common. Because it is common, and I would also add, because we do have a bit of a societal taboo about it, it doesn't get talked about as much. Here in Nevada, I think there have been instances, like I think my home's previous owner actually died by suicide. Nobody talks about it. It's all very, very hush hush. But because murders are higher profile, because they're rarer, they make news. And so when you're trying to judge the likelihood of both of these things, those news stories about murder pop up in your head more than other stories. You judge them as being more likely than they actually are. And the reason that we fall prey to the availability heuristic is because of one of two different mechanisms. So first of all, we can do what is called availability by recall. We can actually think about the number of events that we can recall. So when I'm judging the likelihood of being in a plane crash, well, every time I go to Barcelona for the faculty for the international trip, somehow or other, there always manages to be a plane crash somewhere on the day that I leave. The Germanwings crash happened when I was coming back from Barcelona in 2015. And then the Boeing Air Max crash with Ethiopian Air happened in 2019. So already those are two events that I can bring to my mind very easily when I think about plane crashes. Additionally, we can also use fluency, which is how easy it is for us to bring relative instances to our mind. And we'll talk some more about this next time. We're going to talk about decision making. I'm going to ask you to talk about coin flips. I'm also going to talk about virus outbreaks. And I'm sorry, folks, I wrote these slides before the pandemic. Have a wonderful weekend. Take good care of yourselves. I will give you information about our review session next week. It will be over Zoom on Tuesday night, and I will see you all next time. Bye, everybody.